This is one of the most challenging digital SAT questions that have been released by the College Board. I did see one tutor explaining this question in a very strange way, so I thought I would set the record straight by doing this one next. And here, because I teach using the TI-Nspire CX computer algebra system, that calculator is going to play a big role in this question. A lot of tutors use Desmos, but I find that the calculator just gives you a lot more functionality. So here goes. To start, we're looking at a parabola that is written in this form. However, because they are giving you information about the vertex, it would be very, very helpful for us to go into vertex form, which is this guy. So hopefully you guys are all familiar with this form. Whether this is greater than 0 or less than 0 tells you the directionality of your parabola, and your h and k are going to give you the coordinates of your vertex. So to draw a quick little sketch of this guy, you could potentially do something like this. You have a parabola that has a vertex at 9, -14. So there's one function on the TI-Nspire that's called menu 3.5, and menu 3.5 is effectively going to complete the square so that it can change the equation from standard form into vertex form for you without you doing the grunt algebra work. So I've already done it, and this is the result. So it looks like this. Effectively, you press menu 3.7, and you can literally just write in the general equation in standard form, and it will actually give you what the letters would be if in vertex form. So hopefully you guys are all following here. This guy is going to be your 9, and this guy over here is going to be your -14. So there's a little bit of algebra here where you set -b over 2a equal to 9, and this junk equal to -14. Okay, so if you rearrange this guy a little bit, and the reason I'm doing this is I'm trying to get my expression to show as few diversity of letters as possible. That way I can use menu 3.1 and rearrange the equation. I'm going to show you in just 1 second. So here I've effectively figured out that b is actually equal to -18a. That means I can sub out the b here so that at least in this guy I only have 2 letters instead of 3. So here I'm going to go 4ac minus, going to put the -18a in here and square it, 4a. So this is the SAT. You have very limited time, so I'm going to go ahead and consult my calculator one more time, and this time I'm going to use the menu function menu 3.1, and that is the result. When you put this guy into menu 3.1, it rearranges it for you. So you have that very nice result that c is actually equal to 81a minus 14. Now, what do we care about? We only care about a plus b plus c. So here, if I'm trying to find a plus b plus c, well here, I've actually expressed b in terms of a here, and I've expressed c in terms of a here as well. So very nicely, I can sub out everything so I can have an expression with just one letter. So here I'm going to go a plus -18a plus my 81a minus 14, right? And what is this guy going to come out to? This guy is going to, after some math, come out to 64a minus 14. Now this is where we look very carefully and we remember that we know that this guy is hitting the x-axis at 2 points. That's why we know that it's facing this way instead of the other way, because if it were facing the other way, we would not be having 2 x-intercepts. So what does that mean? That means we know that a has to be greater than 0. Now if I set a to be equal to 0, what's going to happen? If a is equal to 0, then that means that my a plus b plus c is just going to be -14, right? So that's not the case. We know that a is greater than 0. So that means that a plus b plus c has to be what? Greater than -14. And the only answer in the answer choice that's greater than -14 is going to be D, which is -12. Whew!